A plus b equal to 1, a squared plus b squared equal to 2. We want to find a to the power of 11 plus b to the power of 11. For solving this, I want to use Newton's sum. Let me write. But if you don't know this, it's not important. I will explain with basic things so that you will understand. First thing, I want to use Amos identity that a plus b squared is a squared plus b squared plus 2ab. Now, if I raise it to the power of 2, a plus b squared equal to 1 squared, which is 1. So a squared plus b squared plus 2ab equal to 1. From previous part, a squared plus b squared is 2. So I can say 2 plus 2ab equal to 1. Now we conclude. 2ab, if we take 2 to right hand side, 1 minus 2, negative 1. So if we divide both sides by 2, ab equal to negative 1 over 2. So ab equal to negative 1 over 2, a plus b is 1. Now I want to create quadratic function that the roots are a and b. Because the roots are a and b, it is this x minus a, x minus b. Again, it has a formula, but I want to tell you these basic things so that you understand if you don't know the formula. If you multiply, let's consider this is a polynomial p of x quadratic function. It will be x squared minus xb minus ax plus ab. And it will be x squared plus x. And let me write factor from negative x, a plus b plus ab. A plus b is what? Is 1. ab is what? Negative 1 over 2. So it will be x squared minus x minus half. And for this quadratic equation, a and b are roots. Now I say I want to find a to the 11 plus b to the 11. So we define something. We define S0 is a to the 0 plus b to the 0. We know a and b, none of them are 0. Because then ab will be 0, not negative 1 over. So it is not 0 to the 0. A to the 0 is 1 plus b to the 0 is 1, it is 2. We define S1, b to the 1 plus b to the 1. From assumption of the problem, it is 1. S2, it is a squared plus b squared. And we know here is 2. And we want to find S3, S4 to S11 because it is equal by the definition S2. And now I want to tell you an important formula that we call it Newton's sum. So we know x squared minus x minus half equal to 0 for a and b because a and b are roots. And because it is 0, we multiply both sides by 2. It will be 2x squared minus 2x minus 1 equal to 0. We can write this, or let's not multiply, but let's work only with this. So we know that because a and b are roots, a squared minus a minus half equal to 0, and b squared minus b minus half equal to 0. So if we add these two things, then a squared plus b squared minus a plus b minus 1 half minus 1 equal to 0. Now, here it will be what? A squared plus b squared is S2, it is S1, and negative 1 is S0 over 2. So if I write S2 minus S1 minus S0 over 2 equal to 0. Pay attention to these two things. We will see a relationship. S2, the coefficient 1 here, negative 1. Negative 1 over 2, it's same. And you can increase the indices. Means what? We can prove that S3 minus S2 minus S1 over 2 equal to 0. Let's prove this. How? Let me erase this part. Or let me do something. I don't erase, but I do something else. Thing I want to do is to multiply because I want to create S cube. S cube is A cube plus B cube. So I multiply first one by A. And I have A cube minus A squared minus A over 2 equal to 0. Here I multiply by B. It will be B cubed minus B squared minus B over 2 equal to 0. And if we add these two things, A cubed plus B cubed will be S3. Negative A squared, negative B squared will be negative S2. Negative half a plus b will be negative s1 over 2 equal to 0. And we will see this is satisfy that. Again, we can prove it for S4, S3. In general, we can say sk minus 1 minus sk minus 2 over 2 equal to 0. So we conclude sk equal to sk minus 1 plus sk minus 2 over 2. And then we can solve them easily. So let's rewrite all things that we've reached here. Sk equal to sk minus 1 plus sk minus 2 over 2 here. And S0 is 2, S1, 1, 2, 1, 2. Let's write here. S0 is 2, S1 is 1, S2 is 2, S3 is S2 plus 1 over 2, which will be 5 over 2. Next part, S4, 5 over 2 plus S2 over 2, 2 over 2, 1, which will be 7 over 2. S5 is 7 over 2 plus this 1 over 2, which will be 5 over 4. And it will be 4, 2 times 7, 14, plus 5, 19. Let's calculate S6. This previous one, 19 over 4, plus this one over 2, which will be 7 over 4. We are using this formula. 7 plus 19, 26 over 4, which is 13 over 2. Let's calculate S7. We want to reach S11 because the problem says S11 is what? S7 is previous part 13 over 2 plus 5 over 2, which is 19 over 8. And if we use common denominator 8, 4 times 13, which will be 52 plus 9, 62, 71 over 8. S8 is 71 over 8 minus, or let's say plus 13 over 2 over 2 over 4. It will be 81, 84, because we should use common denominator first, 8, 71 plus 26, it will be 797 over 8. S9. Look, this problem has also other solution, but it is so much famous. It also works when we have 3 roots, 4 roots, all of them. In all those cases, Newton's sum is useful. 71 over 16. If we use common denominator 16, 2 times 97, 14, we have 1. And 194 plus 71, it will be 5, 16, 265 over 16. S10 is 265 over 16 plus 97 over 8 over 2, 6. Common denominator is 16, 5 plus 7, 12. I have 1, 9 plus 6, 15, plus 1, 16. We have 1, 2 plus 1, 3. And if you divide by 2, 1, 8, 1 over 8. Now last part, S11, is previous one, 181 over 8 plus 265 over 16 over 2 over 32. So if you divide, it will be 32. 4 times 181 is 4, 4, 8, 32. 724 plus 265. Now, if we add 5 plus 4, 9, 6 plus 2, 8, 7 plus 2, 9, over 32. It is 981, 989, 989 over 32. So let me tell you, try to find in this problem as homework. A19 plus B19. You can also solve it, also solve A11, S11. You can solve it with identities. Do these things as homework and comment your answers right below this video. If you have questions, send message to my WhatsApp number, and please don't forget to subscribe, turn on the bell and like the video. Thanks for watching this video.